Today we're looking at 10.1 and 10.2. We're looking at permutations and combinations. That's when we set up order. Okay, how many different orders could I come up with? And it has a lot to do with probability. Okay, we're going to jump into examples because that's the best way to explain this thing. It's one of the only ways. Let's just say we have 20 students. Okay, I want to see how many different ways I could line them up. Okay, this is one way I could line them up. Now, what if I wanted to change who was standing where? If that person sat there, that person sat there, that one went there, this one went way to the front, this one moved that way, this one moved one, this one moved one. Oh, there's so many different ways to do it. We're going to need to use mathematics to find out how many different ways we can order all of these 20 students. Alright, the answer when we find up getting the math is a big number. It's this big. I think wow, it's a big number. Oh, it's getting bigger. And 0, 0, 0, 0, 0, 0, 0, 0, 0. Wow, I don't even know how to say that number. Well, anyways, let's jump into some other examples, and we'll learn how to get this answer later in the chapter. Let's just say we want an easy one, and we're dealing with choices, okay? Over here we have 3 choices of hats, and we have 2 choices of pants. Okay, let's say that I wanted to make different outfits. How many different outfits could I make? Well, if I had one hat, a purple hat, and I combined it with white pants, okay, there's another one I could do. I could do green hat, and I could combine it with white pants as well. That's a different outfit. Okay, I could take my red hat, and I could combine it with some white pants as well. Okay, now I could take my purple hat again, and I could combine it with some yellow pants this time for a different outfit. I could take my green hat, and I could combine it with some yellow pants as well. And I finally can take my red hat, and combine it with some yellow pants in order to make a total of 1, 2, 3, 4, 5, 6 different combinations of outfits. Okay, but what you're going to notice is that we have 3 hats, okay, and we have 2 pants. When we have choices, okay, we're allowed to just multiply the amount of choices by the other amount of choices that we have, and we got a total of 6 right there. Okay, let's look at one more example. Let me reduce the size of this. Okay, alright, we're still dealing with choices. Let's say I have 5 colors for a car. Okay, those are my 5 choices. And I have 3 choices of brands for a car. So those are my choices for brands, and this is my colors. Let's say blue, purple, red, green, yellow, and orange. And the brands are Mercedes, BMW, and Toyota. How many different kinds of cars could I make? Can you guess? Well, the answer is 5 choices of colors times 3 choices of brands is going to have 15 different combinations of cars. Okay, we're going to keep on doing stuff like this. And examples is the best way to go. Well, we keep moving along. We're going to be looking at license plates, okay? And we can look at the different values that we have in a license plate. We have a number A, G, 6, 7, B, T, P. That's in a license plate. Now, we have to see how many different combinations I could make of a license plate like this. Think about the letters. How many letters are in the American alphabet or English alphabet? Well, there's 26 letters. How many numbers are there? Okay, there are 10 numbers 0 through 9. That could be in one of these different spots. So let's say that we wanted to decide how many different combinations could we have of this type of license plate. Well, if I had a letter and then another letter, and then I had a number and a number and a letter and a letter and a letter. What are all the different ways, how many different ways could I have this? Well, we have 26 choices for letters. So for this one, I have 26 choices. In this slot, I also have 26 choices. In this slot, there's 10 different choices of numbers. In this slot, there's 10 different choices of numbers, and in this slot there's 26 letters. In this slot there's 26 letters, and in this slot there's 26 letters. Because we have just different choices of all these slots, in this slot, this one, this one, this one, and this one, and this one, we multiply them all together to get the total number of possibilities, which ends up being 1,887,137,600. Wow, that's a lot of different possibilities for this type of license plate. Okay, I'm going to erase this answer here because we're going to have to use the space. Let's say that we can't repeat numbers. Okay, so if there's no repeating the numbers or the letters. Okay, let's do it like this. Okay, we're still going to have the same thing. We're going to have L, a letter, and we're going to have a number, and then another number, but not a repeating number, and then a letter, and then a letter. Well, in the first block, I have 26 letter choices, but the next one, I've already used a letter, so now I only have 25 choices. Now in the next spot, I have 10 whole numbers, but in the next one, I only have 9 left because I already used one in this slot right here. Now the next one, I'm going to use 24 different choices of letters. I've used 2 over here, so I have 24 left. Then I have 23 choices, and the last one, I only have 22 choices of letters. The total number of combinations is going to equal 789,360,000 different license plates. That's why you can tell we use these numbers and letters for different license plates to try and keep it the car license plates different. All right, let's see if you can figure out one. Let's say that we had one that was a number, and then the license plate had 2 letters, and there was a number, and then another number, and a number at the end. How many different combinations could we have of this one? Okay, we'll say that we can repeat, just to help people out. Okay, so that's for the first one, we have 10 choices times another 10 choices times 26 choices times 26 choices times 10 times 10 times 10, which ends up equaling 67,600,000 different choices for this license plate. So this is important to notice. The slots in this slot and this slot are all choices we have in each one of these, and when we put how many choices we have in for them, we can multiply them all together and we'll get the total amount of choices and options that we can make this happen with. Alright, here, let's move on. And we are introducing the Factorial. Maybe you've heard about this before, but it's not me being really excited and putting the exclamation point on everything. What it really means, let's say we had 5 factorial. What that really means doesn't mean 5! Yay, 5! No, it actually mathematically means 5 times 4 times 3 times 2 times 1. Okay? Guess what 7 factorial means? You got it. It means 7 times 6 times 5 times 4 times 3 times 2 times 1. Try out 3 factorial. That's going to equal 3 times 2 times 1. We can easily do this one. What is that? 6. There is a function on your calculator that you could use the factorial so you didn't have to multiply all these out. Guess what n factorial is going to be? N is a variable. Well, if you've noticed the pattern, we have some type of n times n minus 1 times that n minus 2, and then times that n minus 3, and so on and so forth. Okay? There's a few little tricks you need to know about. You need to know about 0 factorial. Okay, it actually equals 1. You're saying, Mr. West, what are you talking about? 0 times 0 is 0. No, but think about this. Let's say we had, let me erase this. Let's say we had 4 factorial is actually going to equal 5 factorial divided by 5. Does it make sense yet? Well, 4 factorial really means 4 times 3 times 2 times 1. Okay, if that's going to equal 5 factorial divided by 5, well, that's 5 times 4 times 3 times 2 times 1. It's all divided by 5, right? And then the 5s end up slashing out. So then this equals this. So we're good. So then 0 factorial will equal 1 factorial divided by 1 as well, which equals 1. So in the end, 0 factorial actually equals 1 for all of our purposes. Here's the factorial. So let's figure out why we would need to learn how to use factorials. Okay, if we need to see about order here, alright, I can do it by hand. If we have A, B, C, I want to see how many ways I can put A, B, C in order. Well, I can do A, B, C, I can do A, C, B, I can do C, B, A, I can do C, A, B, I can do B, C, A, and lastly I can do B, A, C. Okay, that ends up being 6 different options for ABC putting into different, okay, orders. Okay, but what does that really mean? Well, in the first slot, if we think about the first slot, second slot, third slot, we could put an A, we could put a B, we could put a C. Like, that's like having 3 choices, and then having 2 choices, and then having 1 choice in the other end. That's the same thing as saying 3 times 2 times 1. Or, here we go, 3 factorial. Okay, now we can use this to order things. So let's say in this next one we have A, B, C, D, E, F, G, which is 1, 2, 3, 4, 5, 6, 7 different ones. Now, I'm not going to waste my time and find out all of the orders, but I know that we're going to have 7 different slots, and there's first slot will be 7 choices, and then 6 choices because I used 1, and then 5 choices, and then 4 choices, and then 3 choices, and 2 choices, and the end slot will only be 1 choice for the last one, and we're going to multiply them all together in order to get the answer, which this actually equals 7 factorial. Alright, so if I wanted to find all the different possibilities, I just use 7 factorial for that, which ends up 7 factorial here ends up equaling 7 factorial equals, if I put it in my calculator, 50, 40. Cool.